Hello everyone, this is a beginner level instructional video on how to use LAMMPS to run a simulation. So before we can run a simulation in LAMMPS and if our machine is a PC, the first step is to install LAMMPS. So for that I have already made a video earlier in my channel named how to install LAMMPS in Windows 10 PC and run an MD simulation. The steps are in the description. Generally it's very easy. The first thing you do is search for install LAMMPS, and then you go to the download an executable for Windows. You download the 64-bit Windows area, you go to the download area, and then you download the exe file. Then you run the exe file, and then you just do the installation, and before running the simulation you just copy the serial file to your simulation file. The process is shown here. You go to program files where the LAMMPS is installed, you go to the folder, you go to the bin file, and then you find a file called lmpserial.exe. You copy that file to the folder where you want to run your simulation, and you paste it there. Then you will run the LAMMPS simulation in command prompt. You open the command prompt and then change the address according to your folders directory, and then you use the cd command to change your directory to the current folder, and then you run the simulation. The syntax is like this: lmpserial.exe, and then the smaller than sign, and then your input file name. If everything is okay, your simulation will start to run as it is shown here. You can see that the simulation is running. I'm just waiting for a few seconds to see what is the screen gonna show. According to your input file, the screen is going to show like the output data you wanted to dump here. And yes, after your simulation is run, you can see what you have actually collected in your log file, the log.lamps file. You can open it. Yeah, you can also allot specific number of cores so that you can actually optimize your running. So you can see I have run it for a very small duration of time. So it is shown that only 100 steps is completed, and the dimensions, the energy like potential energy, kinetic energy, total energy, temperature, pressure, and the energy terms and volume, those things are being dumped here. You can just plot them in Excel or MATLAB, whichever way you like. So that is how you install LAMMPS in your machine, and you can actually run a simulation. Okay. And then another thing, if you don't have any experience in LAMMPS and you want to run some preliminary simulations, then what you can do is go to the LAMMPS EvoCD tutorial. You just search for LAMMPS EvoCD tutorial, and this page will come up. This one, a list of LAMMPS tutorials. The beginner tutorials help you with so many explanations and schemes, like how the steps of LAMMPS simulations are defined. And the other ones, the later ones, are kind of a little bit of advanced simulations. You can start with the first one. Here you can see that the simulation scheme is very well defined, and it is shown like how from setup to the output and analysis of the results go. And the first thing is to download LAMMPS and install it, which we have already done. And downloading a potential. If you are building your system from the scratch, you obviously have to download the potentials. For this tutorial, they have actually given the links from where you can download the potentials required. And this is a typical input file that is That is, a LAMMPS simulation is run based on a script. It's not a programming language, but it has a specific syntax, and it is run based on a script. And this is a typical input script. Generally, to run a LAMMPS file, you need generally to run a LAMMPS simulation, you need a data file, which actually defines all the atoms and their bonds and their angles and everything, and an input file where you define how the simulation on that data file will actually run. And you can see that this is a very clean coding here. The sections are separated by lines here, which is a very good way to run, which is a very good way to write a code. So generally, a typical input file comprises of several sections. In the first section, you initialize the simulation, where you define the how your units will be, how your dimensions will be. Will it be periodic in all directions? How will be the atom style and associated commands? And here you can see that create atoms. Here we are not actually proceeding with a system already built, but we are building it from scratch. Therefore, this section is here. Here you have to define the lattice, and the you have to create a box, and then the lattice associated parameters you have to put here. And then the interatomic potential, you remember that previously you have downloaded these interatomic potentials from here, and now you have to use and define them in your input file. And then you have to define the settings, like what parameters you are going to compute. And then the main section of your input file is running the simulation. Here they are actually running a minimization scheme on their system, on their simulation box, and they are actually also defining like how the minimization and minimization scheme is being carried out. And also the last section will be about how you will actually print your outputs. You want to see the total energy, number of atoms, lattice constant, and cohesive energy. And when it is successfully done, you are just putting a placeholder here showing that it's being run without any error. So you can practice with it. Now let's say we are not actually proceeding with a system from the scratch. Rather, we can use a system that is being produced by another system or a server. In a lot of cases, we cannot actually build the system as we like. The tutorial is just an example of a very small system with a very little amount of atoms here. But let's say if we want to use any system like CHARMM-GUI, let's say you want to use CHARMM force field to run a system, to run an equilibration for DMPC bilayer membrane only system, then you can actually use those existent servers and use their capabilities. For example, let's say if we go to CHARMM-GUI, you just search for CHARMM-GUI membrane builder. If we want to do a 10-10 membrane builder membrane system, then what we are going to do, we're going to go to CHARMM-GUI, and you can see that it has so many features like PDB reader. They can also do solution building or membrane building, or also they can do everything with Martini force field. They can also build polymers, etc. But we are doing the membrane thing, and in membrane we are doing bilayer building. So here you can actually use your PDB file from a source. You can upload a PDB file, or you can build a membrane only system. You just go to the next step, and here you have to select like which kind of lipid you will use. Let's say you want to use DMPC, as I have said, and you have to see you have to set the upper leaflet ratio and lower leaflet ratio. As we have the same number of lipids in upper leaflet and lower leaflet, we just put 1 in both cases. You also have to provide an initial guess, like what will be your length of the system in X and Y. I have put 25 here, as there will be only 10 lipid layers on upper and lower leaflets. And if you click on the system info, it will show you if you have 10 and 10 in upper leaflet and lower leaflet, then you have successfully created your system. If not, then you have to just play with the number a little bit so that you can actually get your expected number of lipids. And then you go to the next step. It will show that it is calculating the system size. It's gonna take a few seconds, but if it's a very big system, it may take longer. Okay, so it has actually went to the next step. It is showing you that the number of lipids and also the crystal angle and the system size. Remember, I have put the initial guess as 25. In 25 angstrom size, it has actually been able to create the system according to our need. And then you have to put ions to neutralize your system. If you put calculate number of ions, for this small system you only need 2 positive and 2 negative ions. Then you go to the next step to build the components. And now you can see that it is in step 4. It has actually created the components, and in every step they will create something to download. You can download everything in this step as a zip file, but I'm going to the next step to assemble the components. They have created the components, now they will assemble it. Now this is going to take a few seconds also. You can see that it will build ion and water box around the system in this stage, and you can see that we have completed the next step, and you can also download the water box and everything in this step, but we are going to the next step, assemble components. Now the components, meaning the lipids and the waters, both are actually created. Now they will be assembled in the box dimension. And now the final step, you can here your force field has 3 options: CHARMM or AMBER, and I'm putting it in the default. And as we want to run LAMMPS, you have to select LAMMPS here. If you use NAMD or AMBER or OpenMM or CHARMM itself, then you have to select those as well. And as I am selecting LAMMPS, it will create a separate folder consisting the LAMMPS readable files. You know, our input was a PDB, but LAMMPS cannot read PDB files, so we have to convert them into LAMMPS readable data file. So that's why we are using CHARMM-GUI. There are other converters as well that can serve this purpose, but for this specific example, for protein or lipid or water box type simulations, you can use CHARMM-GUI with great convenience. You don't have to do anything, just give the required commands according to your simulation. Now it is everything is done. It is in step 6 now. You can see that input files, the good thing is that they provide the input files for the minimization, for equilibration and production. So you just download it, and let's say we have actually downloaded it. Then if you unzip it, you will find something like this. You will find a a folder like this, you can see that in every stage the generated files are actually collected here in step 3, 4, 5 and 6, and you can see a separate folder named LAMMPS here, and in LAMMPS you can find the data file, as I have said, the LAMMPS readable data file that we need, it is here. And also we have the input files required to run the minimization. Generally we run a minimization first, then we run an equilibration with a small time step, then we run equilibration with bigger time step, then we do production or whatever needed. We can actually visualize this. Generally I use Ovito. You can see that it is kind of a little bit of unorganized, but after we run the minimization and equilibration, it will be the energy will be minimized and the system will be more stable. I can show you what happened after the minimization. If you want to see the video that I have actually produced after the running the simulation, we have been able to run a 4 nanosecond simulation on the system, and unlike the amber force field, the CHARMM is showing that they are interacting, but they are not actually like being a globe or that kind of system. So this is an example of how to run a simulation, but there are other things to discuss as well. For example, like how to deal with the our input files. So let's go to an input file. I'm actually discussing it separately because there are so many common errors and the common problems that beginners actually face. I have faced it, and of course you will also face it. So as we have already seen, that a typical input file is like this. You first define your system, your units, your boundaries, then you define your simulation settings generally associated with your data file, like how will be their peristyle, or how you are going to define your atom bond angle dihedral improper. Everything that is actually existent in your data file, you have to actually define them in your input file, and there must be a consistency, otherwise you are going to come up with errors. And then you read the data file. You can see that we are reading the data files, and you this is one important thing, like what kind of equilibration you are running. Generally we run NPT or NVT or NV simulation according to our need, and we set up the associated parameters. For example, we have to define at what temperature we are running this simulation, and then just running a simulation doesn't mean anything. You have to actually very in a planned way dump your results so that you can analyze them very efficiently. For example, you have to define how frequently you are going to see your results, like after how many time steps. And in thermostyle, by thermostyle command, you define like what kind of parameters you are gonna dump, and you have to also write the data after your simulation is run, and for how long you are gonna run this simulation. And the time step is a very important thing. Generally you start the equilibration with small time steps like 1. If 1 is giving you instability or errors, you have to go for smaller time steps. If it is being stable, then you run further equilibration, you can go for bigger time steps. This is to allow the system to cope up with our time integration. And reading our file, whenever you run a LAMMPS simulation, you can actually go through your outputs. Like according to your input file, the log file will actually generate a pile of data, like what you are trying to see as outputs. You can see that we are actually we can actually plot the energy energy terms, we can plot the potential energy versus time to see whether our system is being stable or not. So that is what the log file is doing. You don't want to put everything in your log file. You just dump the parameters you want to see, and you also have to set the interval at which you are dumping the data for them to be meaningful. And now let's come to the errors. What kind of errors you are gonna come up with? First thing is that your data file and your input file must be consistent, otherwise you are gonna come up with error. I have also explained it in this presentation. Actually, it is based on the lipid bilayer building system, and the common errors that are very important, that is very important section. Generally when we run this simulation for the first time, we come up with so many errors, and most of the time they are very self-explanatory. Like you just have to look at your screen and read the error and find out what is going on. Okay, so I have actually explained like how to use LAMMPS to run MD simulation on a system created by CHARMM-GUI, just as I have shown. And some common issues is that time step. Sometimes if you start with a very big time step, your system may be unstable. So it's a good thing to start with a small time step. And input file and data file must be consistent with each other, what I have already said. And the loading and environment should be reasonable. Maybe you can do a tensile test or something like that. Make sure that the loading you are applying or the environment variables that you are setting, the temperature or something like that, those are in reasonable limit. And one thing very important, that you should always go to LAMMPS documentation for everything you want to understand about a LAMMPS script. Let's say you have come up with an input script from someone, and you want to understand what is going on. You don't know what these things mean, so you just have to type this. Let's say you don't know what this thing in units is. What does units mean? You just search here LAMMPS units. You can find a separate page on units. Then you can see that oh yes, in my script here is written that units real. It means that what kind of style of units is using for a simulation. And what does it mean? You have to go through the page. For style real, my units will be like this. There are other styles as well, like metal or C. In those cases, the units will be different. So that's how you have to go line by line to understand what is going on in an input script. Generally, in Yasara or those kind of simulation running systems, you just run a macro. You just put 2 or 3 parameters. You just set 2 or 3 parameters, and then you run the simulation, but you don't know what is going on. The main advantage of these script based simulation is that you can actually understand what is going on by going through the explanations and LAMMPS documentations. So that is what I had to share about the LAMMPS simulation. I hope this will be helpful. If there is any problem, feel free to contact me. Thanks.